Rhombus, circumscribed, angles, this thing. It's geometry. With me, Miss Cohen.
Welcome back, geometers. Today we are doing our second video, and we'll go ahead and fill out our table of contents. It is lesson 1.2 from your textbook. The topic is angles. And I don't know what page you'll be working on. You can fill that out later if you want, but go ahead and find the next available page, and we'll get our notes set up. So please write today's date, whatever it is. It's lesson 1.2. And the essential question is on your homework packet, so you can always write it from there. But today the essential question is, how do you name and measure angles? You've probably talked about angles before in middle school math, and you've hopefully used a protractor before, but for today's lesson, you have to have a protractor. It is key. So let's define an angle. An angle is a figure formed by two rays that have the same endpoint. Okay. So pretty simple. Let's go ahead and draw an angle. And for this angle, it doesn't really matter that you get the exact measure correct. So just make sure you're using a straight edge so that you have nice clean lines. We're going to draw sort of a slanty line, and that's going to be a ray, and there's the end point. So this is the end point. So I need two rays. I've drawn one, but the two rays have to have the same end point. So I can draw another ray anywhere I want to as long as the end point is here, and it will form an angle. I'm going to make mine go sort of straight across. So that's an angle. That's two rays. They have the same end point. Let's go ahead and do a little bit more labeling. We're going to put an A here, a B here. We'll put a point on this ray, point C. And I want to do a couple other things. Let's put a number in here just for fun, number 1. And I want to talk about how to name an angle. By the way, that is the angle symbol. So it's sort of an L, but instead of going straight up, it goes off to the side and it makes a little angle. So naming angles. And maybe we should write angle symbol. It's a useful little guy. So you have several options when naming an angle. This angle has 4 names, 4 different ways you can name it. So the easiest way is to name it by the vertex. So in this case, we could say angle B because B is the vertex. Sometimes that works and it's nice and simple, but to be honest, it doesn't always work. I can see I'm a little out of focus. Let's see here. Hopefully that's better. Okay, and I'll show you an example of when that wouldn't work. But this angle we can call angle B. But we can also call it angle 1 because there's that 1 inside. So we can call it angle 1. And if there's a number like that inside, that's really useful. If you can't use the number because it's not there, and you can't use the letter for a reason I'll show you in a minute, then you have to use 3 letters. So we have a choice here. We can call this angle ABC or angle CBA. But the key is that the middle letter must be the vertex. And that is how to name an angle. Okay, so the vertex, the number inside, or 3 letters where the middle letter is the vertex. So you do a point on one ray, the vertex, a point on the other ray. So that's 3 different ways to name the angle. And I just want to briefly show you why we can't always use that letter outside. If you have, we'll call this a little example. If you have something like this, where you have an angle that has another ray inside of it. Okay, so there's your figure. Go ahead and draw that. I'll give you a few seconds. And let's say this is W, X, Y, and Z. And then I'll put some numbers inside. Number 1 and number 2. So take a minute and copy that down. And I want to know another name for angle 2. Another name for angle 2. And I hope you can see why we can't call it angle X, because I don't know what angle X is. Is it angle 1? Is it angle 2? Or is it this big angle, right? Angle X is the vertex of all of them. So in this case, you have to get more specific. So another name for angle 2, we have 2 choices, but we're going to have to use the 3 letters. So you go ahead and write down what you think the 2 options are, and then check back and see if you're right. So our options are angle Y, X, Z, or angle Z, X, Y. So that's how to name an angle, and I think it'd be a good idea to go ahead and start filling out our left-hand side. We have this vocabulary word here, and then this was kind of a discussion about how to name angles. And I'm going to abbreviate again, how to name angles. All right, let's talk about classifying angles. I hope these are words that you're familiar with. Classifying angles basically means just talk about what type they are. So classifying angles. There are 4 types of angles. There's acute, which is easy to remember because they're the smallest type and they're so cute. So an acute angle is less than 90 degrees. Let's go ahead and draw one. So an acute angle is like the ones we've already drawn. So it's going to take up less than a corner, something like that. Okay. And there's the angle. And the angle is the rotation from one ray to another ray. So even if I drew these out really big and the angle looked gigantic in size, the measure of the angle would still be less than 90 degrees because we're just talking about how many degrees around do you rotate to get from one ray to the other. Then there's obtuse angle. Obtuse is between 90 degrees and 180 degrees. And so an obtuse angle is going to look something like this. You'll have one ray, and then if we were to go straight up, that would be 90 degrees. Anything between here and 90 degrees would be acute. To get obtuse, we have to go on the other side of 90 degrees. So it'll look something like that. And so to get this arrow to turn all the way around to meet that angle, we're going more than 90 degrees. So that's obtuse. And then we have a right angle. And a right angle is a corner. So it's going to look something like that. And we have a special symbol for a right angle. We put this little box in. Basically, we're creating a little square in the corner to show that it's exactly 90 degrees. So a right angle is 90 degrees. And then there's something else called a straight angle. And a straight angle is 180 degrees, and it doesn't look like an angle at all. It actually looks like a line. But if we create a ray here, there's our end point. You can't see. Okay. To create a straight angle, what we're going to do is create another ray coming from this end point, but it's going to go in exactly the opposite direction. And I'm going to use a different color so you can see that I'm really drawing two rays here. That is a straight angle, and that is exactly 180 degrees to turn from one ray to the other. So those are our four kind of angles. I went through that fast, so go ahead and pause the video, make sure you have all this down, and then think about how to fill out the left-hand column with all of this important vocabulary. And then when you're ready, come back. Oh. So we're going to just do several examples here. I'm leaving some room for my key points. So example 1. We're going to start by drawing some angles. So I want you to draw angle PQR with measure of 47 degrees. So take a moment to copy that down. When you're drawing angles, the first step is to draw a ray. So I'm going to draw a ray down here. I'm going to leave myself some space. So I'm going to draw a ray down here. And it doesn't matter which side we put the end point on. I'll put it over here and then there. And I want to think about which letter, P, Q, or R, goes here. So I'm going to give you a few seconds to think about that yourself. So I hope you remember that the middle letter is always the vertex. And so Q is our vertex, which means it's the common endpoint. So that has to be a Q. Now we need to put a point on this ray, but it doesn't matter if it's P or R. So I'll use a P. And now we have to draw our second ray. So I'm going to draw my second ray, but I have to draw it in a specific spot because I need to make sure that it creates a 47-degree angle. So here's how to use the protractor. All protractors have some spot on them that the vertex goes. On this protractor, it's where these two lines cross. On some protractors, like I have another one here, on this protractor, it's where the hole is, and kind of in the middle. So I'm going to put that cross over the vertex. It has to go over the vertex. And then I have to rotate the protractor because I need this ray to be hitting 0 degrees. And 0 degrees looks different on most protractors, but it's going to be kind of the bottom line of these little angle tick marks. So you can see here it goes 10, 20, 30, 40. So the 0 is down at the bottom. So I have to line the vertex up with the center, and then I have to rotate my protractor until that arrow is perfectly hitting 0 degrees. So that's the setup. So now we're going to count around 47 degrees. The most confusing thing about protractors is that every spot has two different numbers. So like this spot has a 20 and a 160, and it can be difficult to figure out which to use. And so if you follow this rule of always starting at 0 and counting up, you'll never get it wrong. So we're at 0. If I'm counting up, I'm obviously going to start at 10, 20, 30. I'm not going to start at 170, 160. I'm counting up from 0. So we go 0, 10, 20, 30, 40. Here's the 40. And then each little mark is 1 degree. So here's 40 there. I'm going to move to the outside because it has the little ones. And then 41, 2, 3, 4, 5, 6, 7. So there's 47 degrees right there. And I'm just going to put a dot at 47 degrees. And then all I need to do is connect the vertex with that dot to make another ray. And as long as you line a straight edge up, you don't have to go all the way out to that dot. You can just go to a spot that's convenient and put array. And then that's P, Q, and so this is going to be R. And we'll go ahead and say this is 47 degrees. And we're going to write a statement here to say that this angle is 47 degrees. There's some notation I need to teach you. So M, that stands for the measure of. So the measure of angle PQR equals 47 degrees. Okay? And then think to yourself really quickly, is this acute, obtuse, right, or straight? And hopefully you figured out this is acute because it's less than 90 degrees. Let's try another example. Example 2. Draw angle, let's see, STU with measure 123 degrees. So I'm going to start it with you because I want you to start it in sort of a different way than we did before, because I want you to know that you can have your first ray oriented in lots of different ways. So this time, let's start by drawing a ray sort of up at the top here. And I'm going to put the end point here and the arrow there. Think for a minute about where to, what letter to put here. And hopefully you figured that has to be T because that's the vertex. It's in the middle. Oh no, I made that look like an I. Okay, T. And then this could be S or U. I'll put an S. And now we need to measure 123 degrees. And so the process is the same, but this time, you know, if I put my protractor here, I'm going to run into example 1. So I'm going to just turn the protractor upside down. It works the same. And I need to make sure that I line that up here with the middle. And then I'm going to rotate my protractor until the ray is pointing to exactly 0 degrees. I want you to go ahead and finish this problem. Go ahead and draw your 123 degree angle. So pause the video, draw it, and then press play and see if you did it right. Okay, 0. I'm going to count up from 0. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. I'm coming out to the outside. 121, 122, 123. So there's my dot. Now all I have to do is connect the vertex to that dot with a ray. Mark that that's 123 degrees. And then put my other point there. Let's write our statement. The measure of angle STU equals 123 degrees. And then think about whether this angle is acute or obtuse or right or straight. And this is obtuse. Okay, just a couple more examples here. So example 3, we're going to all attempt to draw the exact same angle, which is going to be a little tricky. So what I would like for you to do is draw a perfectly horizontal line here, like that. But I need the endpoint to be at a grid crossing, like this. So go ahead and draw that. And then from here, what I want you to do is go down exactly 3 lines, 1, 2, 3, and then to the right 2 lines, 1, 2. That way we all are creating the same angle. So from your endpoint, go down 3 and right 2 and put another point, and then connect with a ray. So there's our angle. Hopefully we all have the same measure, and we'll go A, B, C. And I would like for you to measure this angle. So if you think you know how, go ahead and pause the video now, try it, and then check. If you're not sure how, then you can watch and do it with me. So the process is kind of the same as drawing one. You line the center up with the vertex, and then you rotate until one of your rays, and it doesn't matter which one, is lined up. Now the challenge that some people have is they'll like try to line it up this way, but the problem is now my angle is not in the protractor, right? My angle's over here, my protractor's over here. So you have to turn it, keep turning it until you have something that's gonna work. So like this will work here, because now I have this ray lined up with 0 and the angle is inside the protractor. You could also turn it this way, and that would work. Center's lined up with the vertex, ray is pointing to 0, and the angle's inside. So either way you do it, you should get the same answer. So I'll go ahead and do it this way since I'm nice and lined up. So in this case, the way I've done it, it's this ray that's hitting 0. And so what I'm going to do is count around, starting at 0 until I hit my other ray. So here's 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. And then to me, that's funny, to me it looks like it's about 122 degrees. So basically the same as the one we just did. That was an accident. And we should write our statement. So go ahead and take a few seconds and write the statement just like we did up here. So you should have written the measure of angle ABC equals 122 degrees, or you could do CBA, 122 degrees. Or, frankly, you could say the measure of angle B equals 122 degrees. Either one is totally fine. Okay, so other than that, you are going to see some problems that involve angles and algebra. And so I want to do just one example before we go like that. So example 4. So that doesn't mean anything yet because you don't have a diagram, but go ahead and copy that down, and I'll jot our diagram down. Okay, that's kind of a lot to copy, so feel free to pause the video if you want to. And let's just kind of try to get a sense of what this problem is talking about. So it's saying the measure of angle MLN equals 100 degrees. So MLN is this big angle that goes all the way from here to here. So all of that put together is 100 degrees. And it's asking, what is the measure of angle MLO? So MLO is just this bit right here. So to do that, we're going to have to use some algebra because it didn't tell me specifically what these are, but it did give me some expressions, and that's a hint that I should be able to set up an equation. So one of the things to think about is that I know if I add these two angles together, what are they going to equal? 100 degrees, right? If I take this piece plus this piece, that should be 100 degrees because the entire angle is 100 degrees. So all I have to do is write that out in algebra. I take my first piece, which is 2x degrees, and I add it to my second piece, I'll use purple here, which is x plus 40 degrees. Okay, so that's my first angle plus my second angle, and that has to equal 100 degrees. One piece plus the other piece is 100. And this is an equation that we should all be able to solve. I have some like terms here that I need to combine. 2x plus 1x is 3x. And I know it's been a while since you've solved an equation, but I'd like you to pause the video here and try to solve this on your own. Okay, and hopefully you're back. I got x equals 20. So that's good. I figured that out. I need to go back and look at what the question's asking though, because it says what is the measure of angle MLO, which is this piece. So MLO is 2 times x degrees. Now I know that x is 20. So now I can say that the measure of angle MLO equals 2 times 20, which is 40 degrees. And that's just one example. We have a lot more like this that we're going to practice in class next class, so I don't want you to freak out if this was too much for you, but it is important to kind of get a grasp of how to do this type of problem. So that's it for today. 4 examples. Go ahead and draw a line wherever you are with your notes, and I'll start the summary with you today. So the essential question was, how do you name and measure angles? That's kind of a two-parter. So to name an angle, and we talked about several ways to name an angle, so go ahead and list them all. And then to measure an angle, we use a protractor, but specifically I want you to talk about how to line it up so that you get the right measurement. So a few sentences there, and that's it for today.